Yeah, it'd be a lot easier to. Okay. They ain't alive no more. That's.
Picture this. You're a ground commander pinned down by enemy armor. Air support options flood your radio. F-35s at 35,000 feet, traveling so fast they'll overshoot your position before weapons release. Attack helicopters vulnerable to the same anti-aircraft fire shredding your position. Then you hear it. That distinctive roar. Half jet engine, half angry chainsaw. The A-10 Warthog arrives, flying low enough to see faces, slow enough to distinguish friend from foe, and armed with a cannon that fires depleted uranium rounds the size of beer bottles. Soldiers don't just respect this aircraft, they worship it. But here's what makes the 2026 variant genuinely revolutionary. The upgrades don't just improve the Warthog. They fundamentally reimagine how close air support operates in modern warfare. We're talking about digital architecture that connects ground forces directly to the pilot's helmet display, weapon systems that can engage 16 targets simultaneously, and survivability features that let this beast absorb punishment no other aircraft could withstand. The story begins in the 1960s, when Pentagon strategists confronted an uncomfortable reality. Nuclear weapons couldn't win wars. Infantry support could. American military doctrine was obsessed with supersonic speeds and long-range missiles, but Vietnam exposed the fatal flaw in that thinking. The aging A-1 Sky Raider proved too slow and vulnerable. Jets like the F-4 Phantom flew too fast, screaming over battlefields at speeds exceeding 430 knots, making precision impossible and friendly fire incidents common. Meanwhile, Cold War planners envisioned nightmares, thousands of Soviet tanks flooding through Germany's Fulda Gap like a steel tsunami. The Air Force needed something capable of stopping that armored wave. Not with missiles. With direct, devastating firepower delivered from close range where pilots could see targets with their own eyes. Enter the fighter mafia. Rebellious strategists like Pierre Sprey and John Boyd, who despised the trend toward expensive, complicated aircraft. They wanted crude effectiveness over sophisticated fragility. Their vision was simple, but radical. Build the cheapest, toughest, most maintainable airplane possible, and mount the biggest gun ever fitted to an aircraft. September 1966 marked the launch of the AX program. 6 contractors competed. The final showdown came down to Northrop's YA-9A versus Fairchild Republic's YA-10A. Northrop's design resembled what would become the Soviet Su-25 Frogfoot, with engines mounted at the wing roots. Fairchild's design looked bizarre. Engines perched high on the fuselage, twin vertical tails, and an airframe that prioritized function over aesthetics. That bizarre design won for ruthlessly pragmatic reasons. High-mounted engines avoided ingesting runway debris and masked infrared signatures from heat-seeking missiles. Twin tails provided redundancy if one got blown off. Every design choice screamed survival. On January 18, 1973, the YA-10A claimed victory. The Air Force's requirements seemed impossible. A 30-millimeter rotary cannon, 16,000 pounds of weapons payload, takeoff capability from 4,000-foot dirt strips, all-weather operation. This would be America's first aircraft designed specifically for close air support, and its heart would be a weapon so powerful that engineers didn't mount a gun on the plane. They built the plane around the gun. The GAU-8 Avenger cannon weighs over 4,000 pounds, roughly 16% of the aircraft's empty weight. It's the size and weight of a Volkswagen Beetle. This monster fires depleted uranium rounds capable of penetrating tank armor from 4,000 feet away. The rate of fire hits 3,900 rounds per minute, delivering 65 rounds every second with 80% accuracy. Here's where physics gets interesting. The recoil force from this cannon exceeds 10,000 pounds, actually greater than the thrust of one TF-34 engine. There's a persistent rumor that sustained fire would stop the aircraft mid-flight. That's exaggeration, but the recoil does measurably slow the jet during long bursts. To prevent the plane from yawing when firing, engineers mounted the cannon slightly left of center line, aligning the firing barrel with the aircraft's center of gravity. This forced them to offset the nose landing gear to the right, creating a visible asymmetry. The ammunition mix combines armor-piercing incendiary rounds with high explosives. No aircraft cannon ever built delivers more destructive power. During Operation Desert Storm, A-10s obliterated 900 Iraqi tanks, 2,000 military vehicles, and 1,200 artillery pieces. 90% of AGM-65 Maverick missiles fired during that conflict came from Warthogs. But the gun is just the beginning. What truly separates the A-10 from every other attack aircraft is its ability to absorb catastrophic damage and keep flying. The cockpit sits inside a titanium bathtub, 1,200 pounds of armor, plating thick enough to stop 23mm anti-aircraft rounds. Fuel tanks are self-sealing, filled with reticulated foam to prevent explosions. The hydraulic system features triple redundancy, and if all hydraulics fail, pilots can activate manual reversion, flying the aircraft home using direct mechanical cables. Captain Kim Campbell proved this in Iraq 2003. Anti-aircraft fire shredded her A-10, destroying hydraulics and crippling one engine. The aircraft refused to fall. Campbell landed safely, demonstrating that the Warthog's legendary toughness isn't theory. It's combat-proven reality. And that's just the foundation. The 2026 upgrades take this already formidable platform and transform it into something that challenges every assumption about modern air warfare. The original A-10 flew with analog instruments, steam gauges, and paper maps literally taped to the pilot's thigh. That era ended with the Suite 8 and A-10C upgrade programs. Digital transformation arrived. Two 5x5-inch multifunction color displays replaced the old cockpit, streaming live feeds from sniper and lightning targeting pods alongside moving digital maps. The HOTAS system, borrowed directly from F-15E Strike Eagles, lets pilots control every weapon without removing their hands from throttle or stick. But the real breakthrough came with communication architecture. The ARC-210 radio system revolutionized coordination between pilots and ground forces, especially critical during combat search and rescue missions, where A-10s fly the Sandy roll, suppressing enemy fire at low A altitude to create safe corridors for rescue helicopters. Modern warfare demands more than brute force. It requires surgical precision delivered from beyond the enemy's engagement envelope. New weapon systems transformed the Warthog's tactical profile. No longer does it need to wade into dense air defense networks at low altitude. It obliterates targets from standoff distances that previous generations couldn't imagine. Night operations showcase this evolution dramatically. Pilots wearing advanced night vision goggles hunt from medium altitudes, engaging targets that include enemy warships with AGM-114 guided rockets. Recent Navy exercises demonstrated A-10s coordinating with surface vessels against fast attack craft. Carrying massive loads of precision rockets, a single Warthog flight can neutralize entire swarms of suicide boats threatening carrier strike groups. Then came 2019 and the Suite 9 software package, which fundamentally altered battlefield dynamics. For the first time, onboard computers established direct digital links with forward air controllers on the ground through SADL and Link 16 architecture. Ground troops mark coordinates on tablets, and those locations instantly appear as red triangles on the pilot's heads-up display. Friendly positions update in real time. Blue-on-blue incidents become virtually impossible. The chaos of close-quarters combat gets replaced with crystalline tactical clarity. Multitasking capability defines the upgrade's true power. One button press ripple-fires 6 guided bombs onto 6 separate targets simultaneously. The integrated flight and fire control computer continuously calculates windage, altitude, airspeed, and dive angle, displaying impact points accurate to within meters. Even unguided iron bombs become precision weapons through advanced ballistics computation. GBU-38 and GBU-54. JDAM smart bombs deploy with absolute accuracy in single passes over target areas. Scorpion helmet-mounted cueing systems act as the pilot's augmented reality interface. Head tracking synchronizes line of sight with targeting systems. Look at a target, designate, fire. Tactical symbology projects onto a monocle over the pilot's right eye. When missile warning systems detect incoming threats, red arrows appear instantly, pointing directly at the missile's vector. Pilots react in split seconds without glancing at instrument panels. The weapon's payload itself terrifies adversaries. 16,000 pounds of ordnance distributed across 11 hardpoints under wings and fuselage equals the bomb load of World War II B-17 heavy bombers, but compressed into a nimble tactical platform. The loadout menu reads like a catalog of destruction. Mark 82 500-pounders for soft targets. Mark 84 2,000-pound bunker busters for hardened structures. GBU-39 small diameter bombs represent revolutionary capability. Each hardpoint carries quad packs of 4 SDBs with glide ranges exceeding 60 miles. The A-10 can neutralize 60 indifferent targets from absolute standoff safety, never entering the danger zone. AGM-65 Maverick air-to-ground missiles provide heavy anti-armor punch. Hydra 72.75-inch rockets saturate area targets. Even AIM-9 Sidewinders hang on wingtips for self-defense. The Warthog famously shot down 2 Iraqi helicopters using its cannon during Desert Storm. Modern AIM-9X missiles make it fully capable of defending against UAVs and attack helicopters. Electronic warfare suites carpet the sky with flares and chaff while jamming enemy radars. Upgraded situational awareness means pilots no longer strain their eyes searching for friendlies through smoke and dust. Digital data paints perfectly clear tactical pictures where friend and foe stand in stark distinction. The A-10 evolved into something colder and infinitely more precise than its origins suggested. Suite 10 upgrades integrated APKWS laser-guided rockets, transforming cheap unguided pods into surgical instruments effective at extended ranges. Data link systems enable A-10 flights to share threat information instantaneously. One aircraft spots a target, the entire squadron engages. Development continues. The 41st Flight Test Squadron in Florida finalizes Suite 11 integration. Goals include GBU-39 small diameter bomb compatibility, upgraded cockpit displays, and hardened anti-jam GPS systems resistant to electronic warfare. One strategic feature stands out. The ADM-160M ALD decoy missile integration turns A-10s into electronic warfare platforms, launching dozens of radar-reflective decoys that flood enemy screen with phantom targets, overloading air defenses to clear paths for F-35s and F-22s penetrating denied airspace. Between 2007 and 2019, the massive wing replacement program completed installation of new wings across the entire fleet, ensuring airframes withstand high-intensity combat operations for decades. Rejuvenated mechanical hearts paired with modern digital brains guarantee the Thunderbolt's dominance extends well past 2030, defying every prediction of obsolescence. But hardware upgrades only tell half the story. The philosophy underlying every modification centers on one brutal imperative: survive at all costs. The Thunderbolt's airframe absorbs direct hits from 23mm high-explosive anti-aircraft rounds without catastrophic failure. Hydraulic systems severed, the pilot activates manual reversion mode. Direct mechanical cables and pulleys connected to flight surfaces allow pilots to physically muscle the aircraft home. No computers, no hydraulics, just steel cables transmitting control inputs from stick to tail. Iraq, 2003. Captain Kim Campbell's A-10 took a beating that should have ended in ejection or death. Anti-aircraft fire shredded hydraulics, destroyed one engine, and punched holes through the airframe. The beast refused to fall. Campbell switched to manual reversion and flew the crippled Warthog back to base using pure mechanical linkage. She landed safely. The aircraft was repaired and returned to combat. This incident proved the A-10 exceeds every theoretical durability prediction by wide margins. Maintenance philosophy reflects ultimate pragmatism. Engines swap left to right without modification. Main landing gear assemblies interchange identically. Vertical stabilizers mount on either side. This interchangeability enables rapid cannibalization at austere forward operating bases where supply chains break down. Maintainers strip parts from one damaged bird to resurrect another within hours. The aircraft sits low enough that maintainers rearm, refuel, and repair systems at chest height without specialized ladders or equipment. Even landing gear design prioritizes survival. When retracted, main wheels protrude partially from their fairings. During belly landings, wheels contact ground first, absorbing impact and protecting the airframe from catastrophic structural damage. Every design choice serves one purpose: bring the pilot home. The titanium bathtub surrounding the cockpit weighs 1,200 pounds. This armor tub consists of titanium plates up to 1.5 inches thick, encasing the pilot in an impenetrable shell against ground fire. Fuel tanks occupy central locations, protected by the aircraft structure itself. Self-sealing bladders lined with reticulated polyurethane foam prevent catastrophic vapor explosions when punctured. Fuel delivery systems incorporate dual redundancy. One line gets severed, check valves automatically seal it off, while backup lines reroute fuel through alternate paths. The engines never starve. Destroying all 4 main fuel tanks still doesn't ground the aircraft. Reserve systems provide sufficient fuel for another 230 miles of flight, enough distance to escape kill zones and reach friendly territory. The A-10 was engineered to absorb punishment that annihilates other aircraft. Operation Desert Storm in 1991 showcased the Warthog on history's stage. This single aircraft type obliterated 900 Iraqi tanks, 2,000 military vehicles, and 1,200 artillery pieces. From Balkan skies to Afghan mountains and the war against ISIS, the A-10 remained the most reliable close air support platform ever deployed. It flies low, hits hard, and sows psychological terror in adversaries who hear that distinctive engine whine followed by the cannon's roar. The 422nd Test and Evaluation Squadron reshapes the Warthog's future through experimental tactics and integration programs. Nighttime nap of the Earth flight profiles combined with APKWS, two laser-guided rockets, transform the A-10 into a potential ship killer. Recent naval exercises demonstrated A-10S coordinating with Apache helicopters to hunt small surface vessels. The ability to carry massive loads of precision munitions makes the Warthog devastatingly effective against swarm boat tactics, threatening carrier groups. These capabilities allow independent operations in denied areas, optimizing precision strike potential in volatile modern combat environments where traditional air superiority cannot be guaranteed. The A-10 survives through a combination of redundant systems, armored protection, and tactical flexibility that expensive stealth platforms cannot replicate. The debate over replacing the A-10 with F-35 Lightning IIs effectively ended. Battlefield realities in Ukraine and Middle Eastern theaters prove expensive stealth technology cannot replace the Warthog's overwhelming volume of fire and remarkably low operating costs. The Pentagon confirmed the A-10 will serve well into the 2030s and potentially beyond. The combination of the GAU-8 Avenger cannon and modern smart munitions maintains dominance that no other platform replicates. In a world obsessed with stealth coatings, supersonic speeds, and beyond visual range missiles, the A-10 proves an uncomfortable truth. Grit and raw firepower remain fundamental keys to battlefield victory. Close air support demands aircraft that loiter for hours, absorb damage, and deliver overwhelming firepower precisely where ground forces need it most. The F-35 cannot fly slow enough, cannot carry enough ordnance, and costs too much per flight hour to fulfill this mission effectively. The Warthog's legend grows stronger as modern conflicts validate its design philosophy. Insurgents, armored columns, fortified positions, naval threats. The A-10 adapts and dominates across every scenario. Its survival stems not from technological complexity, but from brutal simplicity executed flawlessly. Redundant systems, interchangeable parts, pilot-focused design, and a cannon that remains unmatched 50 years after its creation. The Thunder will continue dominating skies because no replacement exists. Drones lack the situational awareness and split-second judgment pilots provide. Stealth fighters operate in different realms entirely. The A-10 occupies a unique position as the aircraft that flies into hell, supports troops in desperate situations, and returns home, despite taking damage that would destroy anything else. That's why infantrymen love it. That's why it endures. The Warthog doesn't just survive through armor and redundancy. It survives because the mission demands it, and the aircraft delivers every single time. The 2026 A-10 upgrade proves that winning wars isn't about chasing trends. It's about understanding what actually works when bullets fly and soldiers need cover. While defense contractors pour billions into platforms that look impressive in PowerPoint presentations, the Warthog keeps doing what it's always done, bringing everyone home alive. This isn't nostalgia for Cold War hardware. It's recognition that some problems demand simple, brutal solutions. The A-10 flies slow because pilots need to see targets clearly. It carries ridiculous amounts of armor because getting shot is part of the job description. It mounts a cannon bigger than most cars because sometimes you need to punch holes through tanks. The upgrades don't change this fundamental philosophy. They amplify it. Digital systems make the pilot more effective. Precision weapons extend engagement ranges. Electronic warfare capabilities open doors for stealth assets. But underneath all the modern technology sits the same titanium bathtub, the same redundant systems, the same gun that makes enemy armor crews pray for cloudy weather. Battlefield commanders don't request A-10s because they're cutting edge. They request them because when the situation goes sideways and troops are pinned down taking fire, nothing else delivers overwhelming firepower with absolute precision while absorbing punishment that would obliterate any other aircraft. That's the real lesson here. Sometimes the future looks a lot like the past, just executed better.